Okay, perfect. So that's our cue to get started. Thanks for everyone for joining us again. We've got a star lineup for this discussion today, and I hope we can make this interactive. All of us can get a chance to talk about. It's rare that we can get everybody together from leading journals in our field talking about a key developing area in medicine, specifically AI and scientific publication. We have an excellent, my co-moderator, Dr. Brahmaji Nalamotu, is the editor-in-chief at Circ Outcomes. My boss from JAMA, Dr. Kirsten Bivings-Domingo, is the editor-in-chief of JAMA and the JAMA Network. On the left is Dr. Joe Hill, my former cardiology section chief, and one of my mentors and guides, Dr. Joe Hill, and then editor-in-chief of Circulation, Dr. Sana Al-Khatib, one of the associate editors at Circulation. Dr. Greg Marcus, an associate editor for digital health and cardiology at JAMA, and then Dr. Yulin Swen, she's also an AI editor and associate editor for JAMA and the JAMA Network. So with that, I think we had planned not to do a lot of formal talking, and specifically making sure we had conversations and discussions. But I thought it's always worthwhile to have a few slides just to set us up for a few conversational domains. So I'm going to lead off with elements of where we feel AI in medicine is doing well. And the specific thing that we want to focus on is, what aspects can we learn from that are originally happening that may be avenues which we will see more development in. So AI in healthcare, we've all seen. This is I bring this slide back mostly to say that we have seen this hype before. We have felt a decade before that AI is going to transform healthcare as we know it, and we will automate every aspect of healthcare. And the clinical outcome studies that were done initially, even smaller studies, found no impact. And the key challenge is that these were technology-oriented solutions, and the complexity of the healthcare landscape was somehow not captured, either because of lack of our technology or ability to deliver tools that were problem-oriented. And I think that's where the current focus has been more impactful. It's been problem-focused. It's to try to solve clinically relevant problems. And the pathway to clinical impact has started with the ability to have accessible digital data sources, how we've developed advanced methods to leverage those sources, because initially the digitization of the records that we had access to grew at a faster pace than the methods we were able to use. And then building useful health applications that leverage both of them in synergy. And then finally, we're in a stage of doing rigorous clinical evaluation and bringing forth equitable implementation. And I would posit that only the first three are where we have done good work in. We've been able to do major progress in. And I think the others are areas that we still are building towards and making sure that we make progress. And we know that just to highlight the three areas that we've done well, and we have been able to get longitudinal rich data from the electronic health record. We've been able to build up repositories of unstructured data that were previously fragmented in the health system, and then bringing communities and community-facing technology as part of our health technology landscape. And then methods have grown from just simple machine learning where you identify some signatures of disease to identifying more complex signatures of disease from using deep learning. And then eventually now where we're moving towards models capable of solving many complex problems at the same time using something like transformers or foundation models. And there is an increasing pace of translation to healthcare. So things that happen on the engineering side now go to healthcare much faster. And our big focus has been about augmenting clinical utility of the clinician as they're providing care, using computer as a strategy to enhance their capacity. And what's really fascinating is that leading medical journals have recognized the value of this work and have actually understood that a range of diagnostic and predictive tools that have been built in healthcare settings are now getting closer to predictive diagnostic and prognostication capacities that are closer to clinical application like never before. And that's where we, as some of the editors in JAMA, put out this article asking for a call for papers, looking at studies that if you're an AI investigator, we're looking for patient-centered, quality-enhancing and equity-enhancing care using AI as a strategy to enhance that portfolio. And with that, I'm going to hand it off. There's a lot that's not going well, and I'm going to hand off to Brahmaji to take that on. Thank you.
So good morning. My name is Brahmaji Nalamothu. I'm the editor-in-chief for Circulation Cardiovascular Quality and Outcomes. I'm a good friend of Rohan's, a big fan of his as well. And also just a researcher in general who's been very interested in the space of AI and its applications to health. And I was just going to, just make a few reflections and remarks. And as Rohan said, part of this whole purpose is to engage with just this wonderful group of panelists we have and with the audience. I really enjoy how Rohan actually frames these. I think that, I'll just make a couple of reflections. I do think that we have made great progress in terms of actually the idea of data, as well as methods, and then actually useful applications. I think there's a long ways to go with all three of those. Data is ubiquitous, but at the same time, I think many of us who work in this space realize that there are sorts of, core problems around the data that we are gathering, the quality of the data, and the type of data we are putting into some of these models. And that's created a lot of controversy and issues around that, and I think that that's something that hopefully we'll touch on as a panel. The second is in methods, and I think one of the key issues, and again from the framework or lens as an editor, is just the idea of reproducibility and replication. These are really complicated methods and tools that oftentimes get deployed, and to understand and to appreciate how that works, especially when people are trying to share their science, has been a challenge that our journal has had and really tried to work through. Even just from people basically understanding the methods all the way to being able to understand whether there's a valid result there. And then the last thing I'll just mention is the useful applications. And I've oftentimes said this, right? I mean, when I got into the space of AI, it was because I was so excited. I was like, they're driving cars, right? And I have to admit that when we think about it in ours, we're just like, well, instead of doing a regression, we're going to do a deep learning. And you're just like, I don't know if that's the problem that we can solve. I think that creativity barrier has changed a lot in recent years, and we're starting to see much more exciting applications. I think the growth of some of the foundation models and large language models has really spurred a lot of interest over the last 6 months, and been really excited about that as well. And I'm just going to end with this final thought about the last two pieces that Rohan had mentioned, which is really rigorous evaluation and then equity. And I think that the concerns that drive me are that when we get these papers, it is very difficult for us to evaluate and to assess whether something we feel is a valid and replicable result. Joe Hill has a very famous line about, and I'm going to share it, which is, when he evaluates a paper at Circulation, right, they always ask 3 questions. Is it new? Is it true? And does anybody, right? and that last one is honestly so hard. Many of these studies that we get are like presenting to us perhaps improvements in an AUC curve around discrimination. But understanding how that's actually going to get to the bedside and make a difference in someone's life is really hard. And then the last piece is obviously the piece that overrides much of this, the focus on equity and diversity, and it gets back even to the circle of the data that we are collecting and using to develop these types of models and work. And so these are the things that go through our mind. I have to admit that curve that Rohan showed is the curve of like our interest in papers, right? Like about 5 years ago, we even put out a call for papers, and we just got a huge spike. We had a special theme issue on AI and healthcare. And then we've gone to this level, right? We're like, if you even use the word AI, we're like, desk reject, to like now trying to build ourselves out of this and trying to understand, again, where is the value that we're getting from this growth in science? So I'm going to stop there, and I'm going to maybe just start with Rohan and I thought it'd be great for you guys just to have some reflections and stuff and how you guys think of things. And Kirsten, do you want to start?
Hello, hello. Oh, great. Oh, I love these interjections. They were really, really terrific. So, and I love new, true, and does anybody care? I think that the challenge, I think, for journals at this time is that it's clearly an area that we want to be in. In some ways, it's very easy to stay by our standards that we've always held for the clinical impact of a new innovation. But we're also recognizing that this is a field that involves many different disciplines, disciplines that are coming together to think about the clinical innovation. So how do we engage with science that is emerging, but clearly has a clinical endpoint in mind, to think about at what stage science is in, where do we want to take it and continue to encourage it? How do we draw others into the conversation amongst our readers and our listeners and others who are thinking about this? Because I do think this is an area we don't want to have the technology separate who can actually read and understand a paper. And I think those are the things that we are thinking about when the manuscripts come in. We're thinking about in how we prepare our audience to help to assess and understand papers like this. This is obviously a set of technologies that are going to transform how we practice medicine, how we conduct science, and certainly how we publish. And I think as journals, we have to think about all of those aspects.
So I'll make 2 quick points. You know, we often speak about AI in the future tense. You know, there's still steps that still have to be vetted and optimized. It's not future tense in the publishing world. It is today. It is here and now. And in some ways, you know, it's behind a curtain that we as editors can't see. And the other point I'll make is that whereas data is the currency of our current world, the foundation of biomedical science and its dissemination is honesty. Oh, okay. Thanks to me. is honesty. We have that we as editors, we have to assume that the authors are being honest, and the role that AI may or may not be playing in the way you do your science, write your papers, review your papers, write your grants. You have to be. We have to assume honesty.
Well, thank you. Thank you very much for putting this great session together and for inviting me to participate. I do want to touch on a few things, if I may. First, you know, journals have to prepare for this tsunami of AI papers that we're seeing in terms of making sure that we have the expertise on our editorial boards to assess those papers in terms of validity, making sure that the methodology was right, make sure that we ask the right questions, of course, have the right discussions among us when we have our weekly meetings in terms of, you know, was that done correctly? So validity is so key. But also, I completely agree with the potential impact. Like, we see so many AI papers, people are so excited about AI, as you said, and they feel that if they apply AI, like, automatically a paper is going to be reviewed positively. That's not the case. We have to, as clinicians, make sure that whatever the paper is about, that it will likely be relevant to clinicians, it will be likely relevant to our field, it will advance the field, it will have some potential impact. And I think that's really key. One thing I agree with completely regarding the honesty point is we have to start thinking, I mean, some journals are already doing this, is to make sure that the authors disclose the use of generative AI in putting manuscripts together. Like, many people are now resorting to ChatGPT and other things. So I think it's going to be incredibly important for us to spell out the, you know, regulations and the policies in terms of you need to disclose. And you are ultimately responsible for the content. You can't just take whatever ChatGPT spells out and put it in there without confirming that the data are accurate, without confirming that everything is fine. And then there are regulations in terms of when ChatGPT should not be allowed. For example, you can't apply ChatGPT to change images or figures or things like that that you adopted from other references, citations. So I think all of that needs to be spelled out for all the journals, and I know some journals are doing better job at it than others. I do think that AI is here to stay. I think this is the future. We just need to make sure that as we do this, we do it correctly and continue to make sure that we, publish the best science out there.
Thanks. Just to echo some of what Sana said, and from a JAMA perspective, I would say we are definitely interested in the highest impact, highest quality research related to AI, but keeping in mind that AI is a tool. And so ultimately, don't forget the fundamentals, and the fundamentals are, is this an interesting research question? This comes back to, I think, Joe's third point about who gives a blank. But that's really critical. AI is not by itself not sufficient. The other part is the rigor of the actual AI, which often comes down to what is the reference standard. So if you don't have a strong reference standard, unless you're doing some sort of hypothesis-free discovery project, which also can be very interesting and worthwhile, but in general, if it's about prediction, it's only as good as your reference standard. So these are the sorts of things that we're going to be interested in replication and the quality of the reference standard, but ultimately the importance of the research question.
Thanks, Greg. So I think it's actually really interesting because science is a moving target ultimately, and AI is evolving quite rapidly. And I think in general, the uses of it aren't just in the scientific space, but it's also obviously in the publication space. And I think, policies and so forth need to be transparent, but at the same time, it has to be also very adaptive. You're seeing now in terms of, even from medical education to even, for instance, Harvard College releasing announcements about the use of ChatGPT in classrooms and whether or not you can use that for essay writing, and some courses using it and some not using it. So it's an interesting dynamic now. So I think, again, to echo everyone on the panel here is obviously, there has to be a deep level and sense of trust and integrity in science and rigor and transparency. But I think it's a fast-moving field, and we as publishers, need to be transparent in what we need and what we're looking for, and we also expect that of authors as well, to also be transparent with us and discuss with us, what you are using at this point and what you would like to use.
Well, one thing is we definitely want to hear from the audience, so we're going to encourage you to kind of, please.
Sumit Chugh from Cedars-Sinai. This is a wonderful thing you've done to organize this, and I'd like to offer a brief author perspective. So one of the hats I wear is that in the beginning of the pandemic, our dean asked me to start a new division of AI in medicine. The last 3 years, I have become a student again. And now we have a small but growing division. And what I'd like to, the one point I'd like to make is that there is a disconnect between what the folks are doing that connects AI to medicine and putting out their papers, and what different journals want to see. So for example, our little division that has 5 faculty members, 3 of them are machine learning engineers and 2 of them are clinician scientists. Both sides want to do different things, but everyone wants to publish in the next Lancet or the Nature, because what those journals are giving us is they're laying it out what they really want to see. Because the disconnect is in when you do deep learning or you train a neural network and you put out the data, our audience doesn't really understand the way it's written. So perhaps if our cardiology journals were to put out some kinds of guidance of how to put together something that's easier to explain for AI, I think that would go a long way. The other journals are doing that better. That's just a small thought.
I'd love to hear which journals are doing it better, but I absolutely acknowledge the main point. I think what you're seeing is, as you suggest at the outset, these are different disciplines that usually come from their own traditions, their own sets of journals of how you publish, and we're now looking at a technology that is evolving to clinical application, and usually is trying to look for journals that have readers that are interested in the clinical application. And so that is always going to create tensions. A challenge, I will say, for me in this field is that there are many groups that have stepped in to provide guidelines for AI. There's actually an explosion of developing guidelines for AI. And what I hear from authors is exactly what you're saying. Like, please just give me some practical ways to approach what you want in a paper. And so the development of guidelines oftentimes takes time, and the explosion of manuscripts is moving much faster than the time it takes to develop guidelines, and authors are asking for exactly what you're saying. And I do think as our journals have more experience doing this, it's much more clear what it is that we want relative to what the field is giving us. We'll be able to come at some sort of more happy medium there.
Could I ask a question as people come up for you guys? How important is external validation, and how important is data sharing, specifically in AI? I mean, we were hinting at the issue around replication, understanding it, but anybody have any thoughts about that as you're evaluating papers and science?
I can take this on. I think validation is extremely important, and it's not just internal validation, as you alluded to, but also external validation. And going back to the excellent point that you raised, Sumit, I think it is on us to provide at least instructions to authors in terms of, for example, the need to externally validate. Why not have that on a list? We do that for observational studies for circulation. We have a checklist of things that when we have our meetings and we discuss, well, did they do this, did they do that? And so why not develop a similar checklist, so to speak, related to AI papers in which we say, not only do we want you to internally validate, but we want you to externally validate as well. I do think data sharing is important in general, but we also have to acknowledge the limitations and the restrictions, and that especially in relation to AI and some of the tools that are used, many investigators are not at liberty of sharing their data or sharing the tools that they use to create their models, which makes it more challenging, I think.
You know, we're having two interesting parallel conversations here. Papers about AI, and let's face it, all papers now use AI until proven otherwise, right? People are using ChatGPT until proven otherwise, and right, and so that is our reality, and so I'll leave it at that.
If you're using ChatGPT, you should tell us you're using ChatGPT, just to be clear. And I think that certainly we have, and I suspect at Circulation as well, and this speaks to your point, is we need authors to be transparent about how they're using it, that they're using it. There are other things that I worry about that are clearly not allowed, at least at the JAMA Network. If we've given you a paper to peer review for us, entering any part of a manuscript into a large language model that is not a closed system is actually a violation of a conflict of a confidentiality policy. And it's very important as the technologies continue to advance that we lean on we have to trust what authors are sending us. Authors are the ones who sign, human authors are the ones who sign the authorship forms to say, we've abided by all of the rules, and then tell us how you're using it, right? Because that is important, because as Joe says, we know everyone's using it, so.
And if I may ask you guys, are we at a point where transparency means sharing your AI code? We want to see your code.
So I'm just going to say a couple things. I'm curious. Rohan's got a very active lab in this space, and he's probably been leading in this. I do want to say, if you guys haven't seen it, when generative AI was coming out, Kirsten and Annette, put out a wonderful editorial in JAMA, and we were thinking about the whole thing, and then we were like, oh, they just wrote it. So no, but it's wonderful guidance, and it was very short, simple, clearly written. And it was directed to authors. So I just wanted to say that was a wonderful thing for the entire field. So I really appreciated that. When it comes to code sharing and data sharing, we have tried to really push code sharing because, that should be, something that is much more easily shareable. We've run into same types of situations. I mean, some of the code is proprietary too, right? I mean, people are trying to commercialize some of this stuff, and then you run into those issues as well. The other thing is like, we even in one paper, we put a simulated data set, we had the code, right? And we put it on the AHA Precision Medicine platform, right? And we were super excited about this. We were like, oh my God, we just published like a living paper, right? Not something that was just a PDF that's a version of something that they were doing in the 17th century, right? Like this is the future, we thought. we could find no evidence in 6 months that a single person went to the website and actually used anything. Because this code is deep, it's complicated, and unless you're really interested in that space, so I don't know, I get a little sad when I think about that. But Rohan, what are you guys doing?
I mean, I think, of course, the hygiene practice would say, oh, make sure the data is available and accessible, and then you can replicate every observation on that. From the flip side of that, a bunch of technological development, as Brahmaji alluded to, is actually happening outside the confines of traditional academia. That ensures that a lot of stuff that comes through, I mean, we receive studies now where the primary driver is actually a technological company. And for them, it's inconceivable to have their only limited, their code set is the only thing that separates them from their valuation versus not, and I think it becomes challenging. What we are increasingly trying to do, and we will hopefully do, is that some journals have done it previously effectively, is like having an internal code sharing strategy, which as an author I have participated in, where we find at least one reviewer who commits to reviewing the code in its entirety and uses and reviews the code and gives us an input on was the code adequately designed to address the question. Because our job is not necessarily to, we want open science, we want to make sure if somebody can build on scientific foundations, but I think our bigger push is to make sure the science we're publishing is valid, and that can be done by internal code review. And I think some journals have done that effectively and trying to get towards that. It's just a harder challenge for reviewers to work with.
Thank you so much for this panel. Amazing. My name is Sneha Jain. I work at Stanford in applied data science and implementation. So my question is really around kind of all of the methods advancements that happen in data science and how quickly that's happening. To the point of external validation, there's a lot of debate now in the data science literature about whether kind of temporal, internal, repetitive validation is actually even more important than external validation. And I'm curious, as the field develops from a methods perspective, how journals are staying current on what is actually gold standard. Are there data scientists that are educating everyone on what the current state of the art is, or how do you think about that?
I'll just say in general, it's a really important point. I think that journals have to have, as was previously said, we have to have the expertise. We have to either have the expertise amongst our editors, amongst our statistical editors, our methods editors, or amongst the group that we rely on for peer review. And we have to figure out whether at any point, just not only are we able to understand whether a particular manuscript is producing science that's valid, but we don't also want to miss out on a field that's emerging and the standards have shifted and people are approaching this in a different way. We don't want to miss out because we're sort of anchored on like one way of thinking about it, but the field has moved into different ways. And so this is the challenge for journals in emerging science, is to make sure we have the right people in the room, we have the right people who advise us, which is ultimately what peer reviewers are doing, and that we have enough sort of checks. And so I think that is the challenge for publishing in this space, is that you also have to keep up with a field where the methods are evolving. Absolutely.
I mean, I think I want to add one aspect that I learned as a newly minted editor. I think, of course, the journalistic review process seems pretty opaque as an author. I mean, I, as an author, felt that. But the kind of conversations, the depth of conversations, and the depth of expertise from complementary fields that's reflected in journalistic discussions is just completely lost with that decision letter that comes through. It is rich, it's very exciting, and most importantly, it brings on the point. Somebody would say, but have you read that, specifically that Nature Medicine article about, internal validation versus external validation? And I mean, we bring that up in our conversations consistently.
I think the other thing too is, for us, it's a weekly journal, right? So we are constantly getting information in all the time. We have to be consistently updated because of the fact that we are reviewing consistently, as well as also too is, again, we are fully integrated in terms of the field and having people that can evaluate the science as on the editorial team, but as well as, again, saying about the external reviewers. But I think a big part of that is, integrating more individuals who are in the field of computer science or data science and so forth to make sure that we are, evolving with the most current methods.
Just want to add one thing. I completely agree with your excellent point that we need to make sure that this expertise is well represented on our team as well. I appreciate the need to identify good reviewers who have that expertise. I don't think that's enough. I think at some point, a lot of the journals, if not most of them, will have to add data scientists whose expertise is AI and generative AI. Because when these reviews come back, the way it happens during our weekly meeting is we talk about things and people start chiming in based on their expertise. And if you don't have anyone on the editorial team with that expertise, we're still left with, we're not sure, were their reviews on target, were they good quality? So I think adding data scientists to editorial teams will probably become more common.
James Pirocello from UCSF. I'm going to make an absolutist statement and sort of try to get your input, your feedback on this. My view as a consumer of papers is if someone's using machine learning for some other purpose, I don't really care about the details of their model in general. There's a nice paper that looks at the fractal dimension of the heart, but it's a genetics paper. So I trust that the model's fine, and I'm interested in the genetics, and that part should be open. But when the paper is about the model itself, and I think this is sort of to Joe Hill's point, I care a lot more. And I actually think, so my absolute statement here is I think that papers that don't release the model weights, if the paper is about the model itself, are simply press releases and should not actually be published. If you can't release the weights, good for you. I hope you make a lot of money, but it doesn't sound like science to me. So that's my statement. I'm curious to see how you think about it.
That sounds right to me. You're absolutely right, and I do think that even as we're talking here, we're talking about a range of ways in which a set of technologies are impacting how we conduct science. And so when we are evaluating papers, it might be just as you're saying. There's a whole range, and for some of those, you actually need to see in order for anybody to be able to understand whether this is true. This has always been true in science, right? It's always been true. It's just that I think AI is challenging us because the gaps between who we have traditionally had on our teams to evaluate and what people are using to advance the science is radically different. It's moving at a very fast pace, and there's a range of ways in which this technology is affecting a whole variety of things. And so we have to be specific. So I think that what you're saying is exactly right.
Perfect. I have, we're having such an exciting conversation. We were losing track of time. There are a couple of things that we do want to get through. And I think we'll get the questions again, if that's okay. We decided that we will have our editors present 2 manuscripts that we went through our system. It'll be a few minutes of presentation. And I think they'll bring back some of the conversation points in that light. So I'm going to request Nick Mills to present a paper that was published in Circulation. And then I will bring back everyone for more questions.
Okay. Super. Hello, everyone, and panel. Thank you for asking me to pick one paper. So I'm a cardiologist in Edinburgh. I've been on the board for about 6 years. I naively volunteered right at the beginning to take on AI digital health papers. It was a trickle. I quite enjoyed it. Now that it's a tsunami, it's more of a team effort to manage all these papers. I think I look for much the same when I'm reviewing these submissions as my colleagues here. I like novelty and innovation as well, but fundamentally for our journal, it's the quality of the data, it's the rigor of the ascertainment of the outcome, it is the study design, the attention to detail, not good enough just to give us a rock curve, and external validation and transparency. All of these things are as important, I think, as novelty. And then fundamentally to persuade Joe and Sana and others that we should take this forward, I need to convince them of its priority on its potential impact in clinical practice. And that is often the toughest step, if I'm honest. So in choosing one paper, I found it very difficult because I'm actually very proud of all papers that make it through this journey on behalf of the authors. So choosing one highlight is tough. So I got 3 here that I thought demonstrated the clinical impact of AI in healthcare. The first one gets rid of intravenous gadolinium for MRI. So deep learning for virtual enhancement. Absolutely brilliant piece of work that will change care. The second one, deep learning on the electrocardiogram that doesn't just predict your risk of developing atrial fibrillation in the future, but predicts whether you might have a stroke as a consequence of atrial fibrillation in the future, taking us a step beyond what we currently do in our practice. And the last one is a collaborative project, I think, with Team AliveCore here in the audience, was an attempt to try and provide reliable, real-time measurements of the QTc interval on a smartwatch, so that people that are on drugs that prolong the QT interval can have that monitored without needing to see a cardiologist and have a 12-lead ECG. So all of these papers, really great examples. But the one I was going to really highlight, I am going to highlight because I think it shows some of the challenges we have as editors working with authors on a paper, and also because it's one of our moderators' papers. So, Ron, I handled this paper, and sorry, it took us a long time to get it through, but it was a really interesting experience. And I'll just tell you the story behind it. So, this is a piece of work that when we first got it in, it was almost a desk reject. Another paper with a big ECG database doing a deep learning algorithm on it. I see them every week. In fact, it was rejected, I think, after the first round of reviews. So, but we sometimes admit we make mistakes and revisit decisions. What was distinct and innovative about this piece of work was, unlike the plethora of studies out there that use the voltage signal from the ECG to do the deep learning, this actually used the images themselves, which is a really important step because it makes the technology accessible to everyone and on your smartphone with a camera. That's all you need. Whereas current technologies really have to be embedded in healthcare systems. So this is important, and it was worth revisiting, and it could potentially democratize this technology and make it more available to particularly resource-limited settings. So what did they do? I'm going to briefly try and explain what you did. Sorry. They took up over 100,000 patients with ECGs and echoes that were paired, and they created a model. The performance was very good, discrimination, irrespective of how the ECG looked and was set up and formatted. They demonstrated that this technology can very reliably determine whether you have left ventricular impairment. In fact, the high probability score identified people who were 30 times more likely to have left ventricular impairment. And it importantly performed very consistently by sex, age, and race. And that's something I think we should be looking at with all of our AI models. It also didn't just tell you about your heart function today. It told you about your future risk of developing left ventricular impairment. And they demonstrated the explainability of the tool, which I think is really important for the users when you try and take these technologies forward. But the reason I wanted to highlight it is actually because I felt the process with the editors and the peer review was quite important for this piece of work. So if you're going to pitch a tool to us that is to make this technology available to all, then you at least need to give us access to that technology so that we can assess it. So the initial rejection didn't allow us to evaluate the technology ourselves. But Rowan's team made an online tool publicly available and sent it back to us. And that actually changed the whole dynamic of the review process, because the reviewers started to interrogate the performance themselves, do their own validation. And I remember the editorial board meeting where I put in the chat the link to this. By the time I had summarized all of the reviewers' comments, I had 12 more reviewers telling me how it was performing as they uploaded ECGs in real time to this thing. And that created a very different dynamic as to how you engage with the authors. But to their credit, they went away and created another layer that automated the segmentation, improved the quality, because we all found that when we took smartphone pictures of ECGs, it was completely unreliable. And so they fixed it. And lastly, external validation. We talked about it before. The initial external validation was done in a 250 patient convenience sample, which, given they'd used 116,000 ECGs to train it, didn't seem quite sufficient. But to be fair, they went away and they increased the external validation tenfold and demonstrated that it worked not just in academic healthcare centers, but in rural hospitals and in other healthcare settings around the world. So I thought it was a good story. I hope that the authors thought it was a good experience as well. I'm not sure they did, but from an editor's perspective, I thought it was really enlightening. And if you want to continue the post-publication peer review, this is the QR code, so you can upload your ECGs and give Rowan and his team some feedback. Thanks. No worries.
Great, hello. Let's see. Okay, hello. So my name is Yulin, and I'm an assistant professor at UCSF and associate editor at JAMA and JAMA Network. So I just want to kind of just describe, just in general, why manuscripts are kind of just of interest to us, how we evaluate our manuscripts, oh, sorry about that, and what manuscripts JAMA is looking to publish in the future. And so we have an example paper here to kind of showcase that, a beautifully written paper by Dr. James Puricello. And it is looking to develop a model, a prediction model for ascending aortic diameter using common clinical covariates. And I think, again, why this paper was of interest to JAMA for ourselves was, oh my goodness. It's good. It's doing it. So why this was of interest to JAMA was because of its clinical care relevance, right? This is decisions that clinicians have to make, every day, and it is a very important clinical outcome. And so what we're really looking for is, papers that really are going to influence clinical practice and outcomes in the future. I think what was really important about this paper, too, is that, the exposures were demographic as well as clinical variables. And how does JAMA kind of evaluate these manuscripts in general was, this paper especially used, not just one data set, but 3 different data sets that were quite diverse. And so it had internal validation as well as external validation to it. We do have the author here today, Dr. Puricello, and so I want to actually ask him in terms of, this is a very technically deep paper, and how did you end up, really making it for a clinical audience?
Maybe I'll face the audience. Pardon me for turning my back to you, but so as a cardiologist, I think the initial question was, do we have a good description of ascending aortic diameter in the population in an unselected group of people? And I think the answer is essentially no. And so then once we have a good description in a non-clinical cohort, how much information can we extract from the clinical variables? So our thought was, someone walks into the clinic, you get no other information than that. What could we learn? What could we predict about what would happen if we sent them for imaging? So that was our thought process for how we write this paper.
That's great. Thank you so much. So here's another really great example. This was published in JAMA Cardiology, Natural Language Processing for Adjudication of Heart Failure. A great paper that uses, up-to-date, artificial intelligence methods And you can see how there is an editorial that is written that further adds to it in JAMA. And so you can see how in terms of our journal network, how we work together to be able to pair and couple these editorials as well as studies to be able to not only bring kind of up-to-date science forward, but also to be able to have these type of editorial commentaries that are very important for that type of generation of discussion of these new methods and models. In terms of what manuscripts JAMA is looking to publish in the future, Rohan had mentioned, our AI call for papers. And so again, obviously, there's the standard, RCT trials that we're very interested in. But again, we're really looking for the continuum of scientific, development. So looking at, new models, new methods, prototype testing, real-world implementation. And specifically, we're looking at these 6 domains. So this is of interest to JAMA currently at the moment, that are related to, fairness in AI and algorithms, medical education and clinician experience, global solutions, clinical care and outcomes, and patient-centered care. And then lastly, for our broad clinical audience, we have, multimedia, which, as again, this field is such a fast-moving field that we have these publication aspects, but we also do believe in having, immediate type of information that is provided to, again, a broad clinical audience that is in a multimedia format, from podcast to YouTube to video-based, as well as just online material, where you can come to jamanetwork.com channels AI. So again, these are the type of kind of papers and manuscripts that we are looking to garner, and the discussions that we're looking to have with the authors and the readers of JAMA.
I think the key thing for us would be to, are there any editorial reflections on, so papers that are presented, of course, like we captured many of these aspects before, but is there something that we go ahead? What's the next step for us as we evaluate the next generation of science in this? What would be the areas that we will go after? We will specifically want authors to think about when they submit to leading journals like ours in the field.
Yeah, I guess I would just say, as new technologies emerge, you are looking at the development of the development. You're looking at the validation, the external validation. Ultimately, we're clinical journals. We want to see the clinical outcomes improve. That's where we all want to go. And I think the challenge for us is how do we support science as it continues to build towards that. Without losing readers, so that, because it's important for our clinical readers also to stay involved, and I think that is our opportunity right now, because ultimately I think we're going to be in a situation where, whether it is trials, whether it is pragmatic trials, whether it is whether there are other types of ways that we ultimately assess the impact of a new technology on clinical outcomes, that will still be sort of where we end up. But we have to support the science along the way as we get there.
I think we're currently in this area where there's a focus on, wow, it's amazing that machine learning can do this. And very soon, we need to make a transition, and I think Rohan's paper, so nicely described, is an example of this. It's going to be, okay, but how can we use this in real practice? And how can this be actually extrapolated beyond it's just a conceptual framework to actually being clinically useful? So making that next step into clinical utility, I suspect is going to be a next level.
And as a reminder, AI is a tool, right? And if you'll permit a hackneyed analogy, both of our journals, we don't care about your fancy paintbrush. We want to see the masterpiece you painted with that paintbrush. We don't care about your hammer. We want to see the house you built with that hammer. And it's an amazing hammer. But ultimately, we're clinical journals. We're interested in how this moves the needle in terms of cardiovascular science and medicine.
We do have about 5 or 6 minutes to go, and I've sent a few members of the audience back. So if you have questions that are triggered by now the conversations around these papers, please come back again, and please feel free to ask them.
Hi, I have a question. Xiangjun Li, Dr. Li from Taiwan Kaohsiung Medical University. I have a question is about regarding the external reviewing. Do journals use AI to select the reviewers?
Oh, great question.
I'm sorry, how journals select reviewers?
Yeah. Do you use AI to select reviewers?
Oh,
If so, then how do you validate the algorithm?
we don't do that. We don't do that. I will say that, both of our journals hold ourselves to the standard of being editors, right? We make editorial decisions. We value intensely the advice we get from our external peer reviewers. But maybe you know this, every day we get one that says accept as is and the other one that says reject, okay? It happens all the time. And we ultimately make that decision. And, we currently don't use AI to try to identify those peer reviewers as advisors.
We have databases, so we know people's expertise, and we use that. The editors decide on who the peer reviewers are. We extensively evaluate the quality of reviews, so we tend to know who's going to give us a good review and who's the varying layers of expertise that someone has. But as Joe said, editors make decisions on manuscripts ultimately. We rely on the peer review, and it's important that we have the depth of peer review, but as also been said, we also need to have the expertise in the room on our editorial teams, and ultimately peer review is just advice for the editors on the quality of the manuscript, and the editors make decisions.
Hi, I'm Rayon Ansari from Stanford. I have like a connected question that I wrote down so I don't get tripped up. But I guess we talk a lot about explainability in AI, and it's often considered crucial, especially in a clinical context. And the thing is, I'm an undergrad studying biomedical data science, and a lot of work that's coming out of Stanford is this idea that, and elsewhere, of course, is that there's evidence suggesting that forced explainability can sometimes hinder performance and in the benefits that we can reap out of AI. And it also sometimes can create a false sense of trust, which in itself is a dangerous thing, considering the clinical context. So my first question is, how do we weigh the trade-off between explainability and performance in the development of AI tools, especially in cardiology and medicine? And then the second one, kind of bouncing off of that, is that in the realm of cardiology and medicine, where physicians are regularly using certain tools and of course some drugs that you might not memorize the exact mechanism of action of, right? Could we approach AI similarly? I always think of these really complex DL models as like a nonlinear function, and we don't really know the exact math equation behind it, maybe behind like a SHAP pretty visual or something in the figures. So what circumstances should we also accept an effective black box model? And how can we maintain a healthy skepticism while leveraging its benefits or getting clinical insights from a very explainable model?
So I can try to...
Yeah, I would say it's an excellent question, very thoughtful.
Yeah, great question. And I would say, just to tackle the explainability question, I think this actually applies more broadly to clinical research in general, and that the explainability part is an attempt to understand mechanism. And I would say that we definitely have to have a healthy level of skepticism, as we would for any observational study that is trying to infer explainability or mechanism, which that's all prone to the same confounding. And it doesn't prove causality, so we would want to apply the same rigor, whether it's a randomized trial or some other method, to confirm apparent explainability. Now, the other side is the clinical utility, which is what Joe and I think we're referring to, and these things are not at all mutually exclusive. I don't think the attempt to try to understand, okay, what is it in this machine learning algorithm that it's exactly pointing out? But that's very different in terms of the research question, the research design. Can this algorithm be clinically useful? And that's something that ideally, again, is really tested in a randomized trial. A lot of these first steps are hypothesis generating, but before we apply it to clinical medicine, it's the same as any other sort of predictive tool that we might use.
I just want to add a couple of things. Great questions. Thank you so much. It is important for us as clinicians because I agree, like you as data scientists, you're focusing more on the methodology, making sure that they're valid, that they're robust. And absolutely, we need you to be there to do that. From our perspective as clinicians, we want to make sure that there will be that clinical impact, that the results that you're going to get are going to be helpful to patients. They're going to help us move the needle. And so that's the part that I think is important. So I bring up two important concepts in relation to that. Number one is reproducibility. So many people run these models, what have you, and then when other people try to reproduce those results, they're not able to do so. And so we have to, and that creates uncertainty, it creates confusion for clinicians and patients. And so that's an important one. And then the other is implementation, as was said later. How do you translate the findings into clinical practice and implementation is such an important focus for us.
And can I just say one thing very simply? That is, in fact, the challenge for journals. Our job is to have a deep enough team that we can go deep and understand what's going on, and then we have to come back up and explain it to a much broader audience. That is what clinical journals have always had the struggle of doing, right? Because the authors for papers is not the broad set of readers who read clinical journals. And so we have to, especially in this environment, make sure we have the expertise to evaluate the validity of the science, but then to be able to explain it once and that is our challenge. And so.
So maybe you could explain to me how my iPad works, because I don't know, but I trust it.
Yeah.
I trust my iPad, but I will never trust what lands in my inbox or what Google shows me. You will never get to the point where you trust, even though this device, this tool works really well, we'll never trust what it puts in front of our eyes.
Yeah. I mean, that's a great point. Thank you.
No. Thank you. And actually, that's wrap for us. Yeah, that went by pretty quick. It was a great conversation. Thanks, everyone, for taking the time. Thanks, Brahmaji, for co-moderating, and thanks for all the discussions today. Thank you.